11.4 Properties of Logarithms. It's MA 912, F.1.2, MA 912, NSO .1.6 and 1.7. We're going to use properties of logarithms to evaluate logarithms, rewrite and expand or condense logarithmic expressions, and use properties of logarithms to solve application problems. So properties of logs state that we're going to let a be a positive real number such that a does not equal 1, and let n be a real number. If u and v are real numbers, variables, or algebraic expressions such that u is greater than 0 and v is greater than 0, then the following properties are true. So the product property with a log with a base of a is logs of a u v can be broken up into log of a u plus log of a v. The natural log says if we see ln of u v, we're splitting the two pieces and become ln of u plus the ln of v. If we see a quotient property, log sub base a of u divided by v, then it becomes log sub base a of u minus a log sub base a of v. If we see ln of u over v, then it's ln of u minus ln of v. The power property says that if we see log sub a of u raised to the power of n, then it's going to be equivalent to n times the log base a of u. If we see ln of u to the nth power, then it's going to be n times ln of u. So in example 1, it says we're going to use ln 2 is going to be equivalent by representative 0.693, ln of 3 is 1.099, and ln of 5 is 1.609 to approximate each expression. So they want us to find ln of 2/3. So first then we're going to use our property. Since this is a quotient, it's going to be the ln of u, ln of 2 minus the ln of the v, which is going to be a 3. So we're going to say 0.693 minus our 1.099, and with our calculator we have 0.693 minus our 1.099, and we get negative 0.406 for our piece. In part B, it says ln of 10. Well, n of 10 can be written as a product of numbers. So we're going to rewrite it as ln of 2 times 5, since 2 and 5 were given to us. Now I see ln of 2 plus the ln of 5. So now we're doing 0.693 plus the 1.609. So 0.693 plus our 1.609, and we end up with 2.302. Now our ln of 30, they only gave us the numbers 2, 3, and 5. Well, 2 times 3 is 6, and 6 times 5 is 30. So we're going to rewrite this as ln of 2 times 3 times 5. So for this instance, it's going to be ln of 2 plus the ln of 3 plus the ln of 5. So we're going to say 0.693 plus our 1.099 plus our 1.609. So with a calculator, I'm going to do 0.693 plus 1.099, 0.693 plus our 1.099 plus our 1.609. And we end up with 3.401. Example 2 says they want us to use the properties of logarithms to verify that negative ln of 2 is the same thing as saying ln of 1/2. So first thing, we're going to write this as parentheses negative 1 times the ln of 2, because to give us an exponent piece. This will then say that if we're applying our property rules, we're going to write it as ln of 2 to the negative 1 power, which then actually is ln of 1/2. In example 3, they want us to expand our properties. It says use the properties of the logarithms to expand each expression. So in this one, they gave us log base 10 of 7x cubed. So first thing, we notice that there's multiplication involved. So the first thing we're going to do is we're going to break it up. So we're going to say log base 10 of 7 plus log base 10 of x cubed. Since log base 10 of 7 is already simplified, there is no exponent, but the second one has a power of 3. Log base 10 of 7 slides down. The 3 is the exponent, so 3 is going to come in front of log base 10 of x. In part B, it says log base 6 of 8x cubed divided by y. Notice that there's a division of quotient property. So first thing, we're going to write it as log base 6 of 8x cubed, numerator, minus the log base 6 of our denominator, which is our y. So the second half has already been simplified. The first one has a multiplication property going on with products, so now we have to split those. So we're going to say log base 6 of 8 plus log base 6 of x cubed negative log base 6 of y. The last thing to do, notice that the front and the back end are already simplified, but the second one, the middle one, has an exponent. So we need to finalize it by bringing the property down. So log 6 8 plus 3 times the log 6 of x minus the log 6 of y. On example C, though, it says ln of the square root of 3x minus 5 divided by 7. The first thing to do before we can do anything on this one is you need to change the square root symbol into an exponent. And remember, square root means imaginary 2 in the corner, so it's one piece, so 1/2 power. So we're going to rewrite this first as the ln of 3x minus 5 to the 1/2 power over 7. Now we see the quotient rule, so we're going to write ln of 3x minus 5 to the 1/2 minus ln of 7. And then apply the power rule for that exponent. So we're going to have 1/2 times the ln of 3x minus 5 minus the ln of 7. Now on this piece we don't continue further because 3x minus 5 is contained in the parentheses. In example 4, they want us to condense our logarithmic expressions using the properties that we started at the beginning. It says ln of x minus ln of 3. The minute you see the minus sign, that means it's the quotient property. They both have ln, so it becomes ln of x over 3. The first piece is going to become the numerator, the second piece is going to become your denominator. On B, it says 1/2 log base 3 of x plus log base 3 of 5. So first thing, we need to do our exponent piece. It's saying it's to the 1/2 power. 1/2 as being front means we're raising it to that power. So we're going to write it as log base 3 x to the 1/2 plus log base 3 of 5. Now remember, the 1/2 power is the same thing as saying square root symbol. So now this becomes log base 3 of the square root of x plus log base 3 of 5. Now remember, this is a multiplication property. So these are both positive values, so I can invert it. We're going to end up with log base 3 of 5 times the square root of x. On C, it says 3 parentheses ln 4 plus ln x. So first thing, we're going to do the inside of the parentheses first. Notice that the 3 is attached to the outside, but ln of 4 plus ln of x is asking about the product property. So it's going to become 3 parentheses of ln 4x. Now that exponent is being raised on the outside. So it's going to be the ln of 4x to a power of 3. And the power is being applied to the 4 and the x. So we're seeing ln of 4 to the 3rd power, x to the 3rd power, which 4 times itself 3 times is 64, so ln of 64 x cubed.